Page 135, old book, 3.5, derivatives of trigonometric functions. Pretty much what this lesson is going to be about is me just writing rules up here, which just makes it real nice. You can put them in your notebook and you got them there. They are on 139 or 135 and 141, and you can circle them in your book if you want to do that too, if that's easier. I don't really care. So anyway, as far as derivatives are going, we're going to start out with limits first. Some of these you probably already have. So we've got the limit as t approaches 0. And remember this one? Or maybe we didn't even do this one. Sine of t. So, as t approaches 0, the sine of t will become the sine of 0. And the sine of 0 is 0. Okay? So, we're going to do the same thing with the cosine of t. So the limit as t goes to 0 of the cosine of t is 1. Just because if you put a 0 in here for t, you're going to get 1. Sine of t, this is the one I think that you already have. So the limit as t approaches 0, sine of t over t is also 1. Because the sine of 0 is 0, and I don't know why in the world they get 1, and I'm not going to go through the proof. I guess I could look at the proof and do that, but rather than me prove it, oh, they do prove it, but I don't want to, so because it's 2 pages long.
Oh dear.
All right, so one of the other laws up here, let me get rid of this one, is on page 137, and it's in the middle of the page. It's the limit as t approaches 0. They're going to say that the sine of kt over t equals k. What does k represent? Okay, a number. So for instance, if I had the limit as t approaches 0 of the sine of 4t over t, what they're saying is this whole thing actually equals 4. Because what you're going to do is you're going to take this 4 and move it in front there. And so you've got the sine of, so you're going to have 4 limit as t approaches 0 of the sine of t over t. And we already decided that the sine of t over t is 1. So 4 times 1 is going to be 4. All right. Let's do example 2 on the bottom of page 137. The limit as t. Boy, my limit signs are getting worse and worse. My Algebra 2 class said, Mr. Leiter, give us a problem from the end of the book so that we can see if we can do it. So I went to the end of the book and got them a logarithm. They had no clue what in the world a log. Well, tell us what a log is first. It's like, really? You want me to explain what logarithms are right now?
You should have given them matrices.
Yeah. That book doesn't do matrices.
What? You have to make them do matrices.
I will. I mean, I can't imagine not taking them through a living hell when I took everybody else there.
Yeah, exactly.
So
You can't just miss out on an important part of life.
it's very true.
Build
Okay.
character.
So as t approaches infinity, we're going to rewrite this as the sine of 5t over t squared times the sine of 5t over t squared. Oh, I'm sorry. Yeah, this one. No. Sorry, the squared is not up there.
Oh, no.
I split it apart. So I was thinking adding and subtracting, the denominator would stay the same. So this, if I multiply this together, I'm going to get that back. That's what my sine squared of 5t means, is that I'm taking sine of 5t twice. So I split it up, and all I'm going to do is then take the limit of each one of these. So I'm just kind of writing a whole bunch of stuff that really doesn't need to be written, but yeah, I guess, yeah, I'll put multiplication sign. So, given that in blue there at the bottom, what am I going to get for an answer? 25. Yeah, because this is going to be 5, and this is going to be 5, and then we have our multiplication sign, and then you get the 25. Okay. So, a couple more rules here as far as the limit theory is concerned. On page 137, I gave you the one with k. Another one is the limit as t approaches 0. And somebody watch this down here and let me know when it gets close to 10. Because I'm going to stop it and then reboot it so that they're 10 minutes long instead of longer. Because I don't think YouTube will let me upload something more than 10.
Gets to a point, like, I think you make enough videos or something, then they'll let you do as long as you want.
I think that's the way it is with me now, but I'm not sure. Okay, so that also equals 1. So it's just the inverse of the other one. And then just one more. The limit as t approaches 0 of 1 minus cosine of t all over t equals 0. Okay? So those are all of the limit rules using trig functions. So let's start looking at derivatives of these trig functions. So if we are looking for the derivative of the sine of x, that equals the cosine of x. So if I say, Milo, what's the derivative of the sine of x? It's going to say cosine of x. There's no figure. Okay? The derivative of the cosine of x equals the negative sine of x. Okay, again, the book gives proofs on how to do that. I'm really not too terribly concerned with the proofs right now.
So they don't relate, correct?
The tangent of x, the derivative of the tangent of x equals secant squared of x. Cotangent of x equals negative cosecant squared of x. Okay, two more. The derivative of the secant of x equals secant of x tangent of x. And finally, the derivative of the cosecant of x equals negative cosecant of x cotangent of x. Okay, so that's all you need as far as derivatives to make your life happy and productive.
Zero, 1, 10 minutes.
Okay, thank you.